Hey guys, welcome again to the Maths Club. We're going to be looking at how are we going to carry out arithmetic operations using logarithm. Just like we said, logarithm is just another way of expressing normal numbers, right? And we've seen examples to this fact. So we're going to see, since we can represent normal numbers in logarithm, that means we can be able to carry out arithmetic operations using logarithm. So before we actually begin the arithmetic operation in proper, we need to discuss dividing bar values. In the previous video, we said when we have numbers less than 1, right, and we're trying to convert it to log, we always end up having bar, maybe bar 3 dot something, right? So it is very essential that we discuss how to divide bar values before we actually enter into the arithmetic operations. So we have some examples that we're going to use to clarify this concept, and the first of them is simplify bar 1.7821 by 3. Let me just recap one thing that is very, very important. So bar 1.7821 is not the same thing as saying minus 1.7821. These are two different things. Remember I said in the previous video that we don't do the addition, like the minusing, because we need to preserve the integrity. When we have this, it's like saying bar 1.7821. Remember from there we said it's bar 1 plus 0.7821. These are two different things, and if you use your calculator for this, you see that you have an entirely different value, right? So it's important that we understand that small distinction. All right, so now that we know that I can write this as saying minus 1 plus 0.7821 divided by 3, right? This is like the real representation of this value, but I can't be able to divide this cleanly. I can't be able to divide this cleanly. That will be minus 1 divided by 3. That will give me 0. something, and this divided by 3, that will give me 0. something. No. So what we can do also is say we look for a value that I can replace this minus 1 with, and I can replace 0. So if I said, and that value that we're replacing must be divisible by 3. If I said minus 1 is the same thing as saying minus 3 plus 2. Do you agree that that will be the same thing? Yes, because you're owing somebody 3 naira and you are paying the person how much? You're paying the person 2 naira. That means you're still owing the person 1 naira. So if I can be able to write this as this, that means that I can say, instead of saying minus 1, I can just say minus 3 plus 2 plus 0.7821 divided by 3, right? And if you notice something, we always try to like separate out this minus, but now we have a whole number which is 2, which is positive. So these positive numbers, I can add them together and say minus 3 plus 2 plus this guy is 2.7821. Then I will divide it, right? I will divide this. Remember, we still want to preserve this minus, the minus integrity. We don't want anything to happen to our minus. So I just replace this minus 1 with the number, with the first number that I can divide by 3, which is minus 3 plus 2, right? And I added the two positive numbers together, and that gave me 2.7821. Great. I can now, of course, it's like saying minus 3 divided by 3 plus 2.7821 divided by 3, right? I mean, this is basic. So we can now split it apart and say minus 3 divided by 3, that will be minus 1, plus 2.7821 divided by 3. You can use a calculator for that. So 2.7821 divided by 3, and press my calculator too. This gave me 0.9274. So this is 0.9274, right? And now that we already have it like this, we can now say this our minus 1 plus 0.9274 can be written as bar 1.9274. Great. Let's first see if our answer is correct. And if our answer is correct, then we'll now recap what we actually did. Great, so bar 1.9274. So what did we do? We said that we want to preserve the integrity of this bar 1, right? And you understand how it was minus 1 plus 0.7821 flowing from the previous video. We split it into 2. Then I said I don't want to divide minus 1 by 3 and be having minus 0. something. No. I want an expression that will be able to make me divide whatever I have cleanly, and then I will have a minus value that will be greater than 0. So you can see now I add a minus 1, right? So I just said minus 1 can be written as minus 3 plus 2. right? So that this minus 3 can cleanly divide this 3 and I will have minus 1. So when I replace this, I now added the two positive values, which is 2 plus 0.7821 after I added them together, right? So I had minus 3 plus 2.7821. Now that I have a minus 3 that can divide by 3 and will give me a good value, right? I now split this into 2. So minus 3 divided by 3 is minus 1, and 2.721 divided by 3 is 0.9274, right? Now that I have it back in this minus 1 plus this thing, but in a smaller version, right? My answer now is about 1.9274. I know that it can be a bit strange, but the more we practice, the more we get better. Let's go to the next question. So the next question is saying that we should simplify minus or about 3.8401 divided by 4. Let's simplify it and see. So this is like writing it and saying minus 3 plus 0.8401 and dividing it by 4. So what can I break this minus 3 into that will be able to divide it by 4? We know that minus 3 is the same thing as saying I will just look for a higher negative value or a lower negative value, I don't know, depending on how you want to look at it, right? So that will be minus 4 plus 1. You're owing somebody 4 naira and you pay the person 1 naira. So I can replace this and say minus 4 plus 1 plus 0.8401 divided by 4, right? So if I do this, that will be minus 4 plus 0.8401 is 1.8401 divided by 4, right? So I could split this and say minus 4 divided by 4 plus 1.8401 divided by 4. So minus 4 divided by 4 is minus 1 plus 1.8401 divided by 4. Press it on your calculator and let me see what you have. Great, I had the same thing, and that is 0.46, right? So we already divided this guy by 4. The next thing is that we can't leave our answer like this, right? Because it has to go back to this bar notation. So our answer will be bar 1.46. Let's see if our answer is correct. Great, bar 1.46. Now the next question is saying that we should simplify bar 3.8420 divided by 2. You might want to pause the video and try it out yourself. Welcome back. Let's solve it together. So this is bar 3 is the same thing too, so minus 4 plus 1, right? So this is like saying minus 3 plus 0.8420 divided by 2, right? And that's like saying bar 4 plus 1.0.8420 divided by 2. And I can add, and I'll say bar minus 4 plus 1.8420 divided by 2, right? Let me just do the division from, so minus 4 divided by 2 is minus 2 plus 1.8420 divided by 2. Let's press it on calculators. So I had 0.921, right? So if I replace this, I have it like this. Now I have to take it back to the bar notation, and that will be bar 2.921. Let's see if our answer is correct. Great, bar 2.921. So that's basically it about dividing bar values. Now we are going into operations using logarithm. Now, multiplication operation between numbers is simply the addition of the logs of each number, and then when you add the logs of each number, you convert it using the anti-log table back to a number. Division operation, likewise, is simply the subtraction of the logs of each number and then converting the value that you get back to a number. And to find the power of a number, such as a raised to the power of 3 or a raised to the power of 1 over 3, multiply the log by the power value. So if I was finding a raised to the power of 3, I'll find the log of a, right? And then I'll multiply by the power. In this case, I'll multiply by 3. If it was a raised to the power 1 over 3, I'll find the log of a and then multiply that log by 1 over 3, right? And when I find that answer, I'll convert it to a number. Let's see all of these things in action. Now, this question says, using log table, evaluate 69.24 times 8.31. So for this type of thing, mostly it's very good if you can draw tables, right? If you can draw a table, don't mind my table. So we have number, we have log, right? So the number here is 69.24, right? So let's find the 69.24. Let's find the value of the log. So for 69.24, the first thing that we have to do is convert it to standard form, right? So 69.24 is let me just write it. This is 6.924 times 10 raised to the power of 1. Right, so we're going to go to the log table. 69 under 2 difference 4. 69, this is 0, this is 1, this is 2, 2. 8401, and this is 1, 2, 3, 4 plus 2. So 8401 plus 2, that is 8403. So this is 10 raised to the power of 0.8403 times 10 raised to the power of 1. And the next thing we're going to do is that we're going to add their powers. So that will be 10 raised to the power of 0.8403 plus 1. If I add these two together, I'm going to have 10 raised to the power of 1.8403. So that means the log of this guy of 69.24 is actually 1.8403. So I will write it under this log here. So this is 1.8403, right? And the other value is 8.31. So for 8.31, for me to find the log of 8.31, I'll convert to standard form already. This is like 8.31 times 10 raised to the power of 0. Right, so I'll go to 83 under 1. Let's go to our log table. So this is 83, this is under 0, this is under 1. So that is 9196, which is 10 raised to the power of 0.9196 times 10 raised to the power of 0. So if I add this to that, will be 10 raised to the power of 0.9196. So therefore, the log of 8.31 is actually 0.9196. So I'll put it here, right? This is the log for this other value, 0.9196. Remember when they said something that if it is multiplication that we're trying to do, they said we should add the logs of each of the values. So let's add the logs of each of this value. Right? 3 plus 6 is 9, 0 plus 9 is 9, 4 plus 1 is 5, 8 plus 9 is 17. So I'll carry over 1. 1 plus 1 is 2. So this is the addition. Right? So for me to now find the result back, so that means I have to convert this log back to a number, right? And what will I use? I have to use the anti-log table, right? So if I want to use the anti-log table for this, we have 2.7599. 2.7599. Remember what we did in the previous video, how I showed how to find the anti-log of a value. As I did, like saying you break it into the components part. So this 10 raised to the power of 0.7599 times 10 raised to the power of 2. Right, so this 10 raised to the power of 7599, we're going to use the anti-log table. So we'll go to 0.75 under 9 difference 9. So if any of this is strange, you might want to visit the video prior to this where we're talking about how to read from the logarithm table. So 0.75, what is 9? 9 is the last value. So this is 5741 and difference 9. 5741 plus 12. That is 5753. 5753. Remember what I said again about values from here. 5753, right? It is 5 points, right? Values from the anti-log table is 5 points, like the point is after the first value. So we found this from the last rule. So times 10 raised to the power of 2. 10 raised to the power of 2 is 100. So that means that if I multiply these two guys, this will give me 575.3. So that means that if I find the number, so let me just put a line. If I convert this log back to a number using the anti-log table, I'm going to have 575.3. 575.3. Right, so this is how we actually solve questions like this using the anti-log table. Now let's see if our answer is actually correct. 575.3. Great. The next example says that using the logarithm table, evaluate 0.6924 times 0.0837. Similarly, we are going to have our table, right? So this is the number and this is the log. Forgive my handwriting. So this is 0.6924. So let's look at it. So 0.6924, first thing, convert it to standard form. So this is 6.924 times 10 raised to the power. How many zeros do we have? 1, so minus 1. So I'll go to 69 under 2, difference 4. So 69 under 2 is 8401. Difference 4 is 2. So 8401 plus 2 is 8403. Right, so this is 10 raised to the power of 0.8403. Yeah, so times 10 raised to the power of minus 1. I'll add the powers together. That will be 10 raised to the power of 0.8403 plus minus 1. Remember what I said about values less than 0? You preserve the minus. So the log of 0.6924, right? We already know this. This will be bar 1.8403. So I'll write it here and say bar 1.8403, right? And the other value is 0.0837. So 0.0837. Standard form, 8.37 times 10 raised to the power of minus 2. So we can find 83 under 7 in the log table. So 83 under 7, let's see where 7 is. So this is 9, this is 7. So that is 9227. So this is 10 raised to the power of 0.9227 times 10 raised to the power of minus 2. Right? So next thing is to add the powers. So this 0.9227 plus minus 2. Right? So we already know that the log of 0.0837 is going to be what? Bar 2.9227. So we're going to write it here. So there will be bar 2 plus 9227. 227. Great. So this is for 0.0837. So because there's multiplication in between them, we're going to add both values. Right? So 8 plus 3 is 10. So 0 carry over 1. 1 plus 0 plus 2, that's 3. 4 plus 2, that's 6. 8 plus 9, that is 7. Right? 7, I'll carry over 1. Right? So 1 plus minus 1. 1 plus minus 1 is 0. Right? So 0 plus minus 2, that will be bar 2. Right? So when we are adding like this, we add them like minus 1, minus 2. Right? I know it can be a bit confusing, but the more you practice it, the better you become. So bar 2.7630, right? This is like saying 10 raised to the power of 0.7630, right, times 10 raised to the power of minus 2. So we are going to find 0.76 under 3 difference 0. There's no difference 0 really. So we'll find 0.76 under 3 in the anti-log table. So let's go to the anti-log table. So 0.76 under 3. So this is 0, 1, 2, 3. This is 5794. So this is 5.794 times 10 raised to the power of minus 2, meaning that there are going to be 2 zeros before this guy. So that will be 0.05794. So that means that by the time we find the anti-log of this guy and taking it back to a number, we have what? 0.05794. 0.05794. Let's see if our answer is correct. 0.75794. Great. Which is the same thing as what we add. Great. So that's how we actually just multiply. So the next question says that we should evaluate 7031 divided by 4.911. So we draw a table, then the number here, the log here. So let's take this 7031 first. I'll convert it to standard form first. So that will be 7.031 times 10 raised to the power of 3. So I'll go to my logarithm table and find 70 under 3 difference 1. So let's go. So this is 70 under 3 difference 1 is 1. So that is 0.8471. So that is 10 raised to the power of 0.8471 times 10 raised to the power of 3. Then from the laws of indices, I'll add both powers. So that will be 0.8471 plus 3. Right? And that will be 10 raised to the power of 3.8471. So the log of 7031 is 3.8471. So this is 3.8471. Great. Now the next one is 4.911. So this is 4.911. So for 4.911, this seems like saying 4.911 times 10 to the power of 0. So we'll go to logarithm table and find 49 under 1 difference 1. So let's go. 49 under 1 difference 1. Difference 1 is also 1. So that will be 6911 plus 1, which is 6912. So that is 10 raised to the power of 0.6912 times 10 raised to the power of 0. So this is like 10 raised to the power of 0.6912. So we can now see that the log of 4.911 is 0.6912. So I'll bring it here and say 0.6912. Great. Now, if you look at it, what is joining both of them is division. We said that if it's division, you subtract. So if I subtract this, I'll borrow 1 from here. So this is 11. 11 minus 2, this is 9. This is 6 minus 5, 4. 6 minus 1, 5. 1 here, 7. 14. 14 minus 9, that is 5. 7 minus 6, that is 1.3. So we have 3.1559. Great. So this value now, we want to convert it to the number. So I'll use my anti-log table. So this 3.1559. So we split this into its components. This is 10 raised to the power of 0.1559 times 10 raised to the power of 3. So I'll go to my anti-log table and find 0.15 under 5 difference 9. So 0.15 under 5, this is 1429. Difference 9 is 3. So this will be 1429 plus 3, which is 1432. So this will be 1.432 times 10 raised to the power of 3. 10 raised to the power of 3 is 1000. So if I multiply these two guys, I will have 1432. So this should be our answer when 7031 is divided by 4.911. Let's see if we're correct. 1432. Great. So let's look at the next question. The next question is saying that we should evaluate the cube root of 4087 divided by 59.34. So I could rewrite this and say this same thing as saying 4087 divided by 59.34 all raised to the power of 1 over 3, right, from the laws of indices. So yeah, this will be the number and these are log. So the first number we're dealing with is 4087, right? So let's find the log of 4087. Standard form, that will be 4.087 times 10 raised to the power of 3, right? So we'll go to the logarithm table and find 40 under 8 difference 7. So 40 under 8 difference 7. So this difference 1, 2, 3, 4, 5, 6, 7, that is 8. So that is 6107 plus 8, which is 6115. 6115. So that is 10 raised to the power of 0.6115 times 10 raised to the power of 3. So let's add the power. So that will be 10 raised to the power of 0.6115 plus 3. So it's saying 10 raised to the power of 3.6115. So the log of 4087 is 3.6115. So let's put it here. 59.34 in standard form, that is 5.934 times 10 raised to the power of 1. So we'll go to the logarithm table and find 59 under 3 difference 4. So this is 7731, difference 4 is 3, so that is 7734. So this is 10 raised to the power of 0.7734 times 10 raised to the power of 1. So the next thing is that we're going to add our powers. You can see that by the time you start doing all these things, it's just a series of steps that you have to just be following, and you'll be fine. Right, so this 10 raised to the power of 1.7734. So therefore, the log of 59.34 is 1.7734. So for 59.34, we have 1.774. Right, so what is joining both of them? What's joining them is division, so I'll subtract. Right, if I subtract 5 minus 4 is 1, I'll borrow 1 from here. So this is 11 minus 3, which is 8. 5, I'll borrow 1 from here. 10 minus 7, which is 3. 2, I'll borrow 1 from here. 15 minus 8 minus 7, which is 8. 2 minus 1, which is 1. Right, so I have 1.8381 from 4087 divided by 59.34. So this is what this gave me. So now the next thing I have to find is, open brackets, 4087 divided by 59.34 raised to the power of 1/3. Remember I said something that if you have anything raised to the power of anything, it's just like multiplying the log of the inside value by the power. So we know that the log of the inside value, we already found it to be 1.8381, right? So we just multiply by the power, which is times 1/3. So if you take out your calculator, I want to take it out and press 1.8381 divided by 3. What are you going to have? You're going to have 0.6127, right? So is this 0.6127, which is the log of everything? I will now convert to a number to know what this is going to give me, right? So let's convert 0.6127. So to find the antilog of this, we'll say 10 raised to the power of 0.6127. So 0.61 under 2 difference 7. So 0.61 under 2 difference 7. So this 4093 plus 7. So that is 4100. Of course, we know that that will be 4.100. So that means by the time we convert this to a number, we have 4.100. Let's see if our answer is correct. 4.100. Great. So the next question is saying that we should use logarithm table to evaluate 3.68 squared times 6.705 divided by square root of 0.3581. I can rewrite this as, say, 3.68 all squared times 6.705 divided by 0.3581 all raised to the power of 1/2, right? Great. So when we are dealing with something like this, you can see the top has like 2 values that we're going to add. Then so most times when you have something like this that maybe the numerator is a bit complex, it's better for you to have like 3 lines. So you can have these 3 lines, right? And then just like, normally we use 2 lines, but because of it's a bit complex at the top, so it's best to use 3 lines. So that means the first part of it would be number and log, right? So for this top, let's deal with the top first. So this is 3.68. Let's convert 3.68. So this is 3.68 times 10 raised to the power of 0, right? So we'll go to the logarithm table, 36 under 8. So 36 under 8, that is 0.5658. So 10 raised to the power of 0.5658. I mean, this plus 0, it doesn't change anything. So therefore the log of 3.68 is 0.5658. So let's do it. So this is 0.5658, right? So now that we have the inside, let's take the outside, which is 3.68 all squared. So we'll multiply this value, which is 0.5658 by 2, right? So if you take out your calculator and you press 0.5658 multiplied by 2, what is it giving you? Great. So this gave me 1.1316, right? So we're done with this first guy. Let's go to the next guy, which is 6.705. So 6.705, right, in standard form is just 6.705 times 10 raised to the power of 0. So let's go to the logarithm table. 67 under 0 difference 5. Under 0 difference 5. Difference 5 is 3. So this is 8261 plus 3, which is 8264. So this is 10 raised to the power of 0.8264, right? So therefore the log of 6.705 is 0.8264. So this guy here would be 0.8264, right? So you can see now I have the value of this. I can add them together. So that will be 1.1316 plus 0.8264. Can do that in a calculator. The result will be what I'll put here, which is 1.958, right? So I'm done with the top here. So let's go to the bottom, which is 0.3581 raised to the power of 1/2. So first I'll find 0.3581, right? So let's find the log of 0.3581. It's in standard form. This is 3.581 times 10 raised to the power of -1, right? So I'll go to logarithm table. 35 under 8 difference 1. So 35 under its difference 1. So this is 5539 plus 1, which is 5540. So 10 raised to the power of 0.5540 times 10 raised to the power of minus 1. So if I had these two guys, that would be 10 raised to the power of 0.5540 plus minus 1, right? Remember what we said about finding the log of values less than 1. We don't add these two guys. So therefore, the log of 0.3581 is just about 1.5540, right? So if I have this guy, this would be bar 1.5540, right? So the next thing is to find 0.3581 raised to the power of 1 over 2. I already have what is 0.35. I have the log of it, which is bar 1.5540. So this will just be times 1 over 2, or like basically dividing this by 2. Remember what we said from the beginning? We said if we have something like this, we're going to break it down into something that I can be able to express in terms of 2. So that will be bar 2 plus 1.5540, right? I think this is correct, because bar 2 plus 1 will give me bar 1, right? So I'll divide all of this by 2. So bar 2 divided by 2 is bar 1 plus 1.5540. So 1.5540 divided by 2 is 0.777. I showed how we can actually do this explicitly in the previous section before this. That was at the beginning of the video. So if this is a bit confusing, you want to check the beginning of this video. So by the time I had those two guys, this will give me about 1.777, right? Now what is joining the top and bottom is division, so I'll just subtract these guys. Let me subtract these guys now. So you can see it makes the work clean. So what's at the top is here, what's at the bottom is here. I'll just subtract. 8 minus 7 is 1. 5 minus 7 cannot go, so I'll borrow from here. So this 8. 15 minus 7 is 8. 8 minus 7 is 1. Dot 1 minus minus 1. 1 minus minus 1. Minus times minus is plus, so that will be 1 plus 1. And that will be 2. Right, so this 2. So if I will now convert this value to a number for me to have my answer. So this is 2.18. So this is 2.181. So let's find the antilog of this. So that will be 10 raised to the power of 0.181 times 10 raised to the power of 2. Right, so I'll go to 0.18 in the antilog table under table 1. That is 1.517. Right, so this is 1.517 times 10 to the power 2 is 100. So if I multiply this, so this will be 151.7. Let's see if let me put it here first. So this is 151.7, right? But let me move it down on underline so that is not too close to this guy. So this is 151.7. Great. Let's see if our answer is correct. Great, so our answer is correct. Now the next question is saying that we should evaluate 55.3 times the cube root of 18.5 divided by 1.38 raised to the power of 5 times 2.02 all raised to the power of 1 over 2. So I can write this one as saying raised to the power of 1 over 3. I'm not going to do that. So let's find the log of each of these values first. So the log of 55.3. So that is 5.53 times 10 raised to the power of 1. Right, so I'll go to the logarithm table and find 55 under 3. So 5 under 3 is 0.7427. So this 10 raised to the power of 0.7427 times 10 raised to the power of 1. Right, so if I had these two guys, this will be 10 raised to the power of 0.7427 plus 1. Right, which is 10 raised to the power of 1.7427. So therefore, the log of 55.3 is 1.7427. Let's find the log of the next value. I want to find out the logs together. So this log of 18.5, standard form, that is 1.85 times 10 raised to the power of 1, right? So I'll go to 18 under 5. Let's go to 18 under 5. So 18 under 5 is 0.2672. So 10 raised to the power of 0.26, where is it? 18 under 5, 0.2672. So this 10 raised to the power of 0.2672. times 10 raised to the power of 1. If I had these two guys, that would be 10 raised to the power of 0.2672 plus 1, which is 10 raised to the power of 1.2672. So therefore the log of 18.5 is what? 1.2672. Now let's find the next log, which is 1.38. So the log of 1.38 in standard form, this is 1.38 times 10 raised to the power of 0, because I didn't move the dot in any direction. So I'll go to the logarithm table and find 13 under 8. So let's find 13 under 8. This is 0.1399. So this 10 raised to the power of 0.1399 times 10 raised to the power of 0. So if I had these guys, this would be 10 raised to the power of 0.1399. So therefore the log of 1.38 is 0.1399. Right. Now the next value that I'm trying to find the log is what? 2.02. So so for 2.02, this is like saying 2.02 times 10 raised to the power of 0. So I'll go to the logarithm table and find 20 under 2. So 20 under 2 is what? 0.3054. So 10 raised to the power of 0.30, where is it? 20 under 2, 54. Right, so therefore my log of 2.02 is what? 0.3054. Great, so we have all the logs. Now let's now put it inside the table. So these are number and these are log. So the first number is what? 55.3. When we found the log, what did we have? We had 1.7427. So this is 1.7427. Just to confirm the value. Great. So the next value that we had was 18.5. So 18.5 was 1.2672. 1.2672. This is 18.5. Right, but 18.5 was not what we had. We had cube root of 18.5. So let's find the cube roots of 18.5. right? So this is like saying 1.2672 times 1 over 3, right? Because cube roots is raised to the power of 1 over 3. So if you take a calculator and do 1.2672 divided by 3, that will give me what? 0.4224. So at the top, I'll just be adding 1.7427 plus 0.4224. right? So just to confirm that is everything at the top. Yeah. So this is 2.1651, right? So I'm putting the sum at this side. So I'm done with the numerator. Let's go to the denominator, which is 1.38 raised to the power of 5. So this is 1.38. So for 1.38, what did we have? We had 0.1399. So this is 0.1399. right? But for the 1.38, it was raised to the power of 5. So let's find 1.38 raised to the power of 5. So that's 0.1399 multiplied by 5. So 0.1399 multiplied by 5. This gives me 0.6995, right? So the next part is what? 2.02. 2.02 is 0.3054. So 0.3054. Just to confirm the value. Great. So this is 2.02. So I have these values. I'll just add both of them together. If I add both of them together, this is plus 0.3054. So 0.6995 plus 0.3054 gave me 1.0049, right? So I have the value. So what you generally put to them is a division. So I'll just subtract these two values. So this minus. So the inside of this guy is the subtraction of these two. So this is 2.1651 minus 1.0049, which is 1.1602. So this is 1.1602, right? So by the time you subtract, right? So the next thing is finding the power, which is 1 is raised to the power of 1 over 2. So this my guy inside the brackets, right, dot dot dot, raised to the power of 1 over 2. So the answer I got here is 1.1602, so times 1 over 2, right? This is like saying divided by 2. So this gave me 0.5801. So is this 0.5801 that will now convert to anti-log? I'll convert to a number using the anti-log table. So this 0.5801, this is saying 10 raised to the power of 0.5801. So I'll go to 0.58 under 0 difference 1. So this is 3.802 plus, or 3802 plus 1, that is 3803, right? 3803. So this is like 3.803. So if I carry over to this guy here, so this will be, what will be here will be 3.803. 803. Let's see if our answer is correct. 3.803. Wow. So that's it. And the final question, evaluate 15.05 times square root of 0.00695 divided by 6.95 times 10 to the power of minus 2. So I can write all of this and say 15.05 times 0.00695 raised to the power of 1 over 2 all over, this is 6.95 times 10 to the power of minus 2. If I carry it back to normal number, this is 0.00695, right? So based on all the things that we have done, this is actually your take-home assignment, right? Solve this question with all the steps that will show your workings, right? Let your workings be very clear, because this might be a theory question, right? So let all your workings, the way I do all the logarithm and everything, and I find and I bring it in this table form, and then I relate the final answer. So find the solution of this, right? And then when you do that, you anchor it to 3 significant figures, when then your answer should be 0.00181. So if after you've done this you have 0.00181, congratulations, you now know how to use logarithm to be able to do arithmetic operations. So with this, we've actually come to the end of this particular video. In the next video, we'll be talking about WAEC questions on logarithm from 2014 to 2023. See you guys there.